Hello and welcome. In today's class, we'll be looking at Thevenin's theorem having three loops. We'll be looking at Thevenin's theorem having three loops. In our previous class, we looked at the concept behind Thevenin's theorem, right? We've stated the law and we've seen Thevenin's theorem diagrammatically. Alright, this question given to us, the question says that using Thevenin's theorem, use Thevenin's theorem to determine the current flowing in 4-ohm resistor of the network shown above. The voltage source has a negligible internal resistance. Alright, the steps remain the same, nothing is changing. We said when it comes to Thevenin's theorem, mathematically, Thevenin's theorem, I Thevenin is given as E all divided by RTH plus R, where E is the voltage source of the load resistor, right? When we say load resistor simply means the resistor you are calculating the current, right? In this case, the question says that determine the current flowing through 4-ohm resistor. 4-ohm resistor becomes what? Load resistor. Now, back to Thevenin's formula. What's my E? My E here is the voltage of the load resistor. What's RTH? RTH simply means the equivalent resistance, meaning Thevenin resistance after removing your load resistor. Now, alright, we've short-circuited branch AB, right? We've short-circuited branch AB. After short-circuiting, this is what my diagram looks like. Meaning I've removed the load resistor. You removing the load resistor, it simply means you are removing the resistor you have to calculate the value of current, right? Meaning the unknown voltage, we represented it as VAB. Now, the task here is that recall when we did Thevenin's theorem for two loops. We said in a parallel circuit, voltage must be equal. Now, say you have this circuit, call this A, call this B, C, D, E, and of course F. Right? Now, in this case, what it means is that the voltage of branch AF is equals to the voltage of branch BE and is equals to the voltage of branch CD. So we are saying that in essence, what we are saying is that for a parallel resistor, voltage across each branch, they are equal, right? Now, same idea. From here, say this is loop 1, say this is loop 2, and lastly, say this is what? Loop 3. Now, from here, we've short-circuited this branch, right? Meaning 4-ohm resistor has been short-circuited. Now, observe. In a closed loop, we said we have open circuit and closed circuit. For a closed circuit, what happens in a closed circuit? Current flow through a closed circuit, right? For an open circuit, current do not flow through an open circuit. Now, from here, since we've short-circuited this branch AB, meaning loop 1, current is not flowing through loop 1. So this is loop 1, 2, and 3. So what that means is that there is no current flowing through loop 1. The question is why? Is already an open circuit. Loop 1 is already an open circuit, meaning 4 ohm has been short-circuited from what? Loop 1, right? Now, loop 2, current flows through loop 2 because it is a closed circuit. Similarly, loop 3, current flows through loop 3 because it is a what? Closed circuit. So what that means is that there is no current flowing through what? 10 ohm resistor. Meaning for this circuit, up to this level, for this circuit, you want to determine VAB, right? Since we've short-circuited this branch, what it means is that this 10 ohm resistor, no current is flowing through it. Say the current flowing through here is I1, say the current flowing through here is I2, and say the current flowing through here is I3. It is expected that I1 is flowing through 4 ohm resistor and I1 is also flowing through 10 ohm resistor, right? But since you've short-circuited 4 ohm resistor, meaning this loop 1 becomes an open circuit. That is, current did not flow through an open circuit, meaning no current is flowing through what? 10 ohm resistor. right? That's what you should take note first when it comes to question like this. Just not for different question has different approach the way you solve it. All right, we said for step one, short circuit your load resistor. We've done that. Then having short circuit your load resistor, the next thing to consider is that current won't flow through this 10 ohm resistor, meaning current does not flow through this 10 ohm resistor, right? Next up, now we draw your diagram, we draw your circuit diagram. This is what you have, right? Observe, this 10 ohm resistor is not included here. The question is why? Since I said there is no current flowing through 10 ohm resistor, meaning your next diagram, it is expected that you remove what 10 ohm resistor, though not necessary. For me, I'll be removing what 10 ohm resistor just for better understanding, right? Now from here, not forgetting that I need to get the value of this voltage. I need to get what value of this voltage, meaning the short circuited branch. What's the value of the voltage for the short circuited branch? You know, that's my interest initially from Thevenin's formula. All right, now from here, in this case, since we said voltage is equal for a parallel circuit, voltage are equal, right? For a parallel circuit, voltage are equal. So what it means is that the value of voltage in branch AB is equal to the value of voltage in branch CD, and is equal to the value of voltage in branch EF, and is equal to the value of voltage in branch GH, right? That's what you are supposed to have. But for this question, it does not work like that. The reason is because from here, since you are removing this 10 ohm resistor, you observe that this 6 and 8, they are in series. 6 and 8, they are in series, meaning the value of voltage in this resistor will be different from the value of voltage here. So what it means is that normally what I'm supposed to have is that the value of voltage in each branch, they are equal, right? But up to this level, what you should take note or how it works for similar question, for this question, is that the value of voltage in branch AB is equal to the value of voltage in branch CD. Call this one. Then 2, the value of voltage in branch EF is equal to the value of voltage in branch GH. Call this 2. Right? We are saying that for parallel circuit, the value of voltage must be what? Equal. Meaning, how it works here is that the value of voltage in branch AB is equal to the value of voltage in branch CD. That's one. That's equation 1. Equation 2 is saying that the value of voltage in branch EF is equal to the value of voltage in what? Branch GH. Call this equation 2. Now let's solve. Meaning in this case, I'm interested in equation 1. I'm interested in what? Equation 1. Since from equation 1, I have what? VAB. Meaning by the time I know the value of voltage of CD, then the value is equivalent to what? Branch AB. Now, let's see how it works. From equation 2, we said that the value of voltage in branch EF is equal to the value of voltage in branch GH, which is equal to what? 28 volts, right? From the question given, GH is equal to 28 volts. Obviously, the value of voltage in branch EF will also be what? 28 volts. So let's represent that using this arrow. So you have what? 28 volts. All right, that's from equation 2. Now from equation 1, which is the value of voltage in branch AB is equal to the value of voltage in branch CD. Question mark. Let's obtain this value. Now, how do you get this value of voltage? To get this value of voltage, we are going to use branch CD. Whatever value you'll be getting for branch CD, meaning that value of voltage in what? Branch AB. Now, from here, what we are going to make use of is this resistor, which are 6 ohm resistor and 4 ohm resistor. We are making use of what? 6 ohm resistor and 4 ohm resistor. Now 6 ohm and 4 ohm resistor, we've discussed what we called current division rule, current divider rule, right? We've seen the concept behind current divider rule. Now what we are going to be using here is called voltage divider rule. Voltage divider rule. But for a voltage divider rule, applying the concept of voltage divider rule to this question, from here I'm having 6 ohm resistor and 8 ohm resistor. I want to know the current, I want to know the voltage flowing through 8 ohm resistor. I want to know the voltage flowing through 8 ohm resistor, meaning branch CD. Applying by voltage divider rule, it means that the voltage in branch CD is equals to 8 ohm resistor, or divided by 8 ohm resistor plus 6 multiplied by what? This voltage, meaning 28 volts. 28, right? By voltage divider rule, we want to obtain the voltage flowing through branch CD. We want to obtain the voltage flowing through branch CD. Mathematically, voltage divider rule, meaning VCD, is equals to 8 ohms, which is the resistor in that branch, or divided by that same value of resistor in that branch, which is still what? 8 ohm resistor, plus 6 ohm resistor, multiplied by what? The voltage given from the question, which is what? 28 volts. By the time you put this in your calculator, you have that VCD 16 volts. Alright, now from here, what it means is that VCD, go back to equation 1. From equation 1, we have that VAB is equals to VCD, right? Meaning the voltage in branch AB is equals to the voltage in branch CD. Then we've gotten 16 volts, meaning I have a 16 volts. That is the value of the voltage, meaning the value of the voltage for the load resistor, which is VAB, is equals to what? 16 volts. 16 volts. What it means is that from your Thevenin's formula, we state that I Thevenin is equals to E over RTH plus R. Obtain the value of E to be what? 16 volts. Then from here, our R is our load resistor, which is what? 4 ohms. Then lastly, let's solve for what? RTH. Let's solve for what? RTH, meaning Thevenin equivalent resistance. Now, how do you get your equivalent Thevenin resistor? Same idea. We said when it comes to equivalent Thevenin resistor, you are calculating the equivalent resistance of other resistor, right? Now, this is your diagram. Removing your load resistor, you are left with this resistor. So this resistor, meaning you are calculating their equivalent resistance. You are calculating the equivalent resistance. Now, in this case, the question says that the voltage source has negligible internal resistance. The voltage source has negligible internal resistance. The question, given from the question, you are told that the voltage source has negligible internal resistance. Now, what it means is that you're removing this 24 volts. From the question, I want to solve RTH, meaning I'm considering this resistor, the resistor I'm left with. I want to solve their net equivalent resistance, right? Meaning I'm going to remove this 24 volts. Now, you removing this 24 volts, what it means is that you are removing your 24 volts, replacing it with what? Internal resistance. You are removing this 24 volts, replacing it with what? The internal resistance of the 24 volts. But observe from the question is saying that it has what? Negligible internal resistance, meaning the internal resistance in this case is what? 0. It has negligible internal resistance, meaning 0. Now, one thing you need to take note as well is that as you are removing this 24 volts, your 2 ohms is going as well. You are removing what? 24 volts, meaning you are also removing what? These 2 ohms. Earlier I said say this is loop 1, loop 2, and loop 3. Now, your 24 volt is in loop 3, meaning you removing this 24 volt, which is in loop 3. You're also removing the resistor attached to what? Loop 3. Attached to what? Loop 3. Right? Now, since you said you are removing this 24 volt, meaning I'm also removing this what? 2 ohms. Replacing it with what? The internal resistance of this 24 volts. But since the question says that it has negligible internal resistance, meaning what? 0. So you join your circuit, you have this. You join your circuit. Alright, now from here, this is my diagram. This is my diagram. We've removed this 24 volts and we've also removed this for 2 ohms. Now, I believe you know why we remove these 2 ohms. We are removing 2 ohms just because 2 ohms is in what? Loop 3. So the idea here is that as you are removing your 2 volts, as you are removing your 24 volts, you're also removing your 2 ohms, replacing the internal resistance of this 24 volts, right? Let's say in this case, or from the question, you are giving that the internal resistance, let's say you are giving the internal resistance of 24 volts to be 6 ohms. You are giving it as what? 6 ohms resistor. Meaning, what I'm supposed to have, my next diagram, I'm supposed to have it in this manner. 6 ohm resistor. Observe, I've removed 24 volts itself and I've also removed what? 2 ohms. I've also removed what? 2 ohms. So the concept here is that you're removing this 24 volts, you're also removing what? This 2 ohm resistor, replacing it with the internal resistance. But from here, the question says that the source voltage has negligible internal resistance. So meaning I have my diagram. I have my diagram in this manner. Alright, having said that, let's solve for our RTH. Solving for RTH, your 8 and 6 ohm resistor, they are in parallel and they are also in series with 10 ohm resistor. Meaning this circuit can be drawn as this. You can withdraw the circuit as this. Right? Meaning this is 10 ohm resistor, this is 6 ohm resistor, and this is 8 ohm resistor. So what this means is that 6 ohm and 8 ohm resistor, they are in parallel and they are in series with what? 10 ohm resistor. In that case, let's solve for 6 ohm resistor and 8 ohm resistor in parallel, then in series with 10 ohm resistor. Solving 6 ohms and 8 ohm resistor in parallel, we have that 6 multiplied by 8 or divided by 6 plus 8, right? Which is equals to 48 over 14, and this gives us 3.428 ohms, right? Now, we've solved 6 ohms and 8 ohm resistor in parallel, meaning that our next diagram, we have it in this manner. This is 10 ohm resistor and this is 3.428 ohm resistor. Now, solving this, we have that our RTH is equals to 10 ohms plus 3.428 ohms, which is equals to 13.428 ohms. Therefore, our E, which is the voltage of the load resistor, we got 16 volts. Our RTH, Thevenin equivalent resistance, we got 13.428 ohms, and of course the load resistor R is equals to what? 4 ohms. Next up, let's record Thevenin's formula and substitute this value so as to get the current flowing through 4 ohm resistor. Thevenin's formula, we have that I Thevenin is equals to E over RTH plus R. Substituting the respective value, we have that I Thevenin, which is equals to current flowing through I Thevenin, which is equals to the current flowing through 4 ohm resistor, is equals to 16 all divided by 13.428 plus 4. By the time we put this in our calculator, we then have that I Thevenin, which is equals to 4 ohms, 0.918 ampere. Alright, so meaning this comes to the end of this question. So what it means is that given a similar question like this, the steps remain the same. Given a similar question, the steps remain the same. First thing first, recall your Thevenin's formula, which states that I Thevenin is equals to E over RTH plus what? R. Then your first step, short circuit your load resistor, meaning whatever value of current, whatever value of resistor you have to calculate the current, short circuit the resistor. When we say short circuit, meaning you are disconnecting it. So once you've done that, your next step, meaning once you've done that, so what it means is that the loop where you have the load resistor, the other resistor, no current is flowing through it. So in this case, we are having 10 ohm resistor present in the loop where we have our load resistor, which is 4 ohms. So that is, no current is flowing through 10 ohm resistor, right? Then next up, calculate the voltage. Calculate the voltage of the load resistor. Calculate the voltage of the load resistor. And the concept is that for a parallel resistor, the value of voltage across each branch, they are the same. But in this case, how it works is that the value of voltage in branch AB is equal to the value of voltage in branch CD. Say equation 1. Equation 2, the value of voltage in branch EF is equal to the value of voltage in branch GH. Say equation 2. Now, by equation 2, it means the value of voltage in this branch, which is 28 volts, is equal to the value of voltage in this branch, which is what? 2 ohms. Right? Next up, following equation 1, which says that the value of voltage in branch AB is equal to the value of voltage in what? Branch CD. The question is, how do we then obtain the value of voltage in branch CD or branch AF? From here, it is obvious, from what we did previously, it is obvious that we can only get the value of voltage. We can only get the value of voltage in branch CD, then equate it to the value of voltage in what? Branch AB, right? The concept behind this is voltage divider rule. We are going to make use of what? Voltage divider rule. Using voltage divider rule, we are going to get the value of voltage in branch CD, then later equate it to what? Branch AB. Meaning you've calculated the value of voltage for the load resistor, which is what? E. Then get your RTH. Solving for RTH. RTH simply means the equivalent resistance after removing the what? Load resistor. Right? Now, how it works is that you are going to remove your 24 volts. You removing your 24 volts. Also take note that you are removing this 2 ohm resistor. Right? The overall idea here is that removing 24 volts, you are replacing it with what? Internal resistance. But in this case, the question says that it has no negligible internal resistance, meaning we don't have a resistor to replace it with, meaning 0. So meaning that from here, from this complex circuit, we have reduced it to something of this nature. Then you observe that 8 ohms and 6 ohm resistor, they are in parallel in series with this. Then simplifying this, you end up getting 13.428 ohms. 13.428 ohms, right? Now, meaning you've gotten your E to be 16 volts, your RTH 13.428, and your R to be what? 4 ohms. Then lastly, substitute into your Thevenin's formula. Substitute into your Thevenin's formula. So this is how it works. For similar question, having 3 loops under Thevenin's theorem, and the question says that calculate the value of voltage, calculate the current flowing through any resistor. Say the resistor AB, say the resistor in branch AB or the resistor in branch GH. This is what you should implement. The steps remain the same. Alright, if you find this video helpful, do well to share your thoughts in the comment section. Give this video a thumbs up Also check the description below. I'll be dropping a link to our WhatsApp group. You can join the WhatsApp group to ask for any information. See you in the next video.